Hi there, and a warm welcome to my Banishing Technical Debt Practice Guide. My name is Dave Litton from the Projex Academy. Now, this particular training is somewhat different from my normal project management focused training. Nevertheless, anyone that is involved with projects in some way, whether you're sponsoring them, whether you're a project manager, or whether you're an engineer or specialist of some industry, then technical debt is something that you really need to understand, manage and control. And the concept of technical debt was coined by a gentleman called Ward Cunningham way back in 1992. And he was applying the technical debt metaphor to the development of software, in particular using agile and adaptive project methods. Nonetheless, it's important that you understand right from the outset that technical debt can apply to any project in any industry, using any method, and indeed developing any type of product or service. And so, although this practice guide will give you plenty of examples of the origins, that is via agile adaptive processes, the main thrust of this training is about managing technical debt in any industry. So before you and I roll up our sleeves and get stuck in to the first slide, it's probably worthwhile quoting Ward Cunningham when he defined technical debt. He said it like this: shipping first-time code is like going into debt. A little debt speeds development as long as it is paid back promptly with a rewrite. Again, you can see he's referring to software coding. Ward continues, the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Indeed, entire engineering organizations can be brought to a standstill under the debt load of an unconsolidated implementation. So whenever I start talking about code, I want you to think about the specialism that your projects are involved with. And that includes what I would call broadly physical products, ranging from domestic products such as food blenders, vacuum cleaners and the like, all the way to new applications for mobile phones and other software. So let's you and I kick off by looking at what this course involves. Now, I've called this Banishing Technical Debt as a practice guide for business owners, project managers and engineers. Indeed, I want you to see technical debt as something that is a danger to all businesses. And because of that, banishing technical debt needs the buy-in and support from everyone within an organization. And my practice guide consists of 14 video modules, this of course being the first. And as I've said in the accompanying handbook, this will be your guide to rescuing profit and customer satisfaction from the silent company killer. That was a term that Forbes used to describe technical debt. So here's the structure of this course. As I've said, in 14 modules, this being the first, unearthing knowledge work and projects. So we won't dive into more detail about technical debt until the second module. The reason for this is logical, in that, first of all, you and I need to fully understand the various different types of projects, agile and non-agile, and consider non-software projects. So in module 1, that's exactly what I intend to do. At this point, I don't intend to take you through a summary of every single module, as this slide is merely just a reference for what's coming up. But you may take a quick note here that module 3 and 4 looks at the symptoms and consequences of technical debt, whereas module 6 through to module 9 focuses on steps to fixing it. Module 10, 11 and 12 shows you how to service the debt, whereas module 13 I focus solely on the management of technical debt within predictive or non-agile projects. Bringing us to the final module, module 14, where you and I will discuss technical debt in other disciplines, other than software of course. So by the end of all 14 modules, not only will you have a full and thorough understanding of what technical debt is, you'll know the approaches needed to manage and minimize it, and also the way in which it manifests itself in various different projects across just about every industry that you can think of. So next, let's you and I look at the problem at hand. Now, technical debt has become more evident over the past decade, as of course the pace and horizon of change continues to expand. This causes the drive for all organizations to meet that change and get their products and services out in the marketplace as soon as possible. So you see, the debt itself is a backlog of work caused by not doing regular cleanup, maintenance, and standardization during product development in order to make future work easier. Just like getting a loan, let's say on your house or a new car, with a high interest payment where you take little attention to paying off the principal of the loan, then you will continue to be paying off interest, probably to the point where you have so much interest you can't pay it back at all. The analogy there would be where the future of your business becomes critical and highly likely to fail. So to do it well, you need to stay on top of new technologies as well as a full understanding of your internal systems, also of your teams, as well as strategic initiatives and business goals. Here you can see I'm making it clear to you that this is not just an engineering problem or a technical problem. I'm using the word technical debt because it's well understood and it's fine for our purposes. However, perhaps a more appropriate term might be specialist debt or even business debt, because that ultimately is what will occur if it's not managed. Now, shortcuts and assumptions help developers to iterate quickly, and here I'm referring to product or service developers in any industry. So although these shortcuts and assumptions help you to get products, hardware or systems or software out there in the market, such shortcuts and assumptions are central to accruing technical debt because, of course, of the push to deliver new features and new products as the pace and the horizon of change continues to expand. Now, left unaddressed, this debt bogs down systems, crashes software, and causes many months of delay in product and service releases. And it's a fact that technical debt could paralyze the future of your company while preventing business agility and competitiveness. So the concept here is that incurring technical debt allows you to release quickly today at the cost of slower delivery in the future. You'll learn as I take you through these modules that incurring technical debt in the first place is a bad thing. In fact, it's almost inevitable. What's important is to understand the consequences of whatever technical debt you have incurred and make sure that you pay it back. Because if you don't, as I've said here, you will indeed get slower delivery in the future. And it's important to understand that technical debt is not just bug fixing or dealing with issues. Those still occur on any project or endeavour that is launching new products or services. And of course, with borrowed money, we've all done that and we all do it, and businesses do it for sound financial reasons. You can do something sooner than you might otherwise, but then, until you pay back that quote-unquote money, you will be paying interest. So fast-track release of your latest product or service is indeed a great way to start generating revenue and gain market share. You'll learn that there's several types of technical debt, and this is one of them called strategic debt. But you will ultimately need to go back, and as you learn things about your product once it's out there in the marketplace, you would repay that loan by refactoring or refining your product or service to reflect your experience as you acquired it. Let me put that another way. Once you've gone through and developed your product to meet an urgent and critical launch date, you will have learned things that you could have done better or different. That's a fact of life. And in the software industry, we talk about refactoring. It's changing the software under the hood, if you will, without affecting the features that the users and customers would see. So if you're not developing software, then perhaps refining would be a more generic term that you might apply to let's say, a physical product. So rushing products out the door and learning new things, but never putting that learning back into the product, is like borrowing money, thinking that you will never need to ever pay it back. Big mistake. And that's why technical debt is termed by Forbes as the silent killer. So developing a product over time by only adding new features and never reorganizing or refining it, then eventually that product will be loaded with technical debt, and all efforts to work on that product or service will take longer and longer. Just like trying to repay a credit card with a large interest rate. As you scrape and save to try and repay the loan, and as you do so, each month the interest increases, it will get to a point where you would in effect be bankrupt. Technical debt is the metaphor that's used here, and it has exactly the same consequences for any organization. So what you've got to be careful of is that if you don't service the technical debt, you could end up only paying interest and not in fact reducing the principal at all, thereby being forever in debt. So before we finish with this slide, just be aware it really isn't just about bug fixing, and we'll be discussing that in a later module. So let me start off by sharing with you what's known as a traditional project. It's often called waterfall, although that's only one form. A better description here would be to call traditional projects predictive. And this diagram helps you to see why. You'll probably be familiar with phases or stages of product development, let's use that term, where you start off with analysis, then you design, and if it's got involved with software, you're doing coding. If it's not software, you're developing, and then you test it to make sure it works, and then you pass it on to the operational area, which could be your end customer. In other words, sales and marketing will start selling it. You'll also be familiar with traditional project approaches, that you have what used to be known as the iron triangle. It's actually a pyramid, as you can see. And with a traditional project, because you analyze and develop your requirements up front and get them agreed and fixed, then the features that you're going to develop within that project are fixed. So in a traditional project, the only thing that is left to vary is the time, that's your schedule, your end dates, your key milestones, or costs, where you adjust the resources on the project to help deliver those features. Of course, there's another aspect, which is quality. One of the ways of shipping early is to adjust your quality metrics so that you can do that. Perhaps not as much testing, perhaps not as much documentation, perhaps not fully developing all of the features. So this is called waterfall because, in effect, each of these points here will often be called a gate review, where you deliver some particular aspect of your entire project. It's a key milestone. It will be a review to check what you've done, and at that point get an approval to move on to the next stage or phase. The words I've used here are very generic, and in your industry you may use different terms, but the purpose here is the same. So plan-driven processes, so named because they attempt to plan for and anticipate upfront all the features a user wants in the end product. In other words, you produce a detailed plan as part of analysis here, so that when you start design, everything you do thereafter is based on what the plan says. Now, plan-driven development actually works well for problems that are well defined, that are predictable, and unlikely to undergo any significant change. The construction industry here is a good example. Although it's possible to change some of the interior design partway through building, let's say, a new apartment block, you certainly can't go back and adjust the foundations when you're working on the 26th floor, if you take my point. And you would be absolutely right if you're guessing that technical debt is just as prevalent in traditional plan-driven development approaches. So I've used the word here knowledge work. And frankly, knowledge work is where normally you would want to use something other than a predictive approach, which is why Agile comes into the picture. But for now, let's stick to the previous slide. Here's your project manager. Here's your detailed work plans. I've shown a little snapshot of a Gantt chart. Those will be loaded up with resources, and you'll have some form of technical team or specialist team, depending on the products that you are creating and ultimately delivering within this project. Please remember, a project is merely a means to an end, and that is, it's one of the ways in which you can create change and develop new or enhanced products and services. Generally, the approach here is command and control. And here I've reminded you again of the typical life cycle, either through phases or stages, from the beginning to an end of a traditional project. So the analogy here is, as you go through these, it could be seen as a railway journey. This is predictable since it runs on rails and can be planned in advance in detail, which is why, of course, you can produce railway timetables. So that's a good analogy, if you will, for the predictable approach in projects. The traditional controls you'd use here is the project manager would give out packages of work to the team who are creating the products, and this would be tracked using percentage complete in some form, whether it's capturing actual hours, planned hours and remaining hours, and tracking that through so that each work package is being tracked and controlled, hopefully to finish on time. The project manager therefore gives out these work packages within a given stage, and it continues as you go through the various stages. For example, analysis, design, build and test. Here you can see at the end of every stage you have a review point where you agree that, for example, in this case, the design is complete and has been approved and agreed before you start building. So it's called the waterfall approach, since you've got to complete all the design before you start the first part of building. So let's now look at the Agile approach, also known as adaptive methods. Now, in an Agile approach, not all the processes are well defined, and an example here is when carrying out knowledge work, hence the title of these first few slides. When faced with such uncertainty, it's more of a process of trial and experiment in order to determine what works, what problems are encountered, and then incrementally build on those learnings ultimately to a successful project. And there are various Agile approaches. Agile could be seen as an umbrella term, if you will, and this is a different way of managing projects. The project manager, for example, will not be in command and control mode. Indeed, some Agile methods say that you wouldn't use a project manager at all, but some other role, such as a product owner. But this training isn't about writing software, and it's certainly not about teaching you Agile, although I will need to make quite clear as we go through the various modules that you have a good understanding of both adaptive and predictive methods. So the resulting processes within an Agile project will be what's known as iterative and incremental. Now these two terms are often considered to be one and the same, but they're not, and I shall explain that in the next slide. So the processes will be iterative and incremental with frequent reviews and adaptation. By adaptation, we mean adapting the features and indeed how you are implementing them. So this is known as an empirical process and is suitable for all those projects that are characterized by uncertainty and risks. Yes, I know what you're thinking, and that is that all projects have risks, and that's true. However, we'll see shortly that knowledge work is a lot more uncertain than, for example, a construction type project. And here in Agile, we turn the iron triangle on its head. We've still got the four main aspects, but here, within an Agile project, we have a fixed time and a fixed cost. You will have maybe heard of the term sprints and time boxes. Well, this is exactly how Agile works. Within, say, a traditional stage or iteration, as Agile would call it, you may have one or more sprints. And sprints have a fixed end date, and they're fixed costs simply because you'll have a fixed team working within each sprint. Now, that team may change for different sprints, but because we've got the same team, and since human resources typically make up 90% of the cost, then the cost can be controlled to a very tight margin. What's variable, however, in order to meet that deadline, are the features themselves. You will learn as we go through, there's something called a product backlog. Now, it's nothing more than a prioritized list of each of the items, or features if you will, that need to be delivered and converted into product or products by the end of the project. See this as a pack of cards, if you will, where each card describes a particular feature. This will be continually shuffled, not to make it random, but in terms of progress thus far and unstoppable prioritization. What we mean by prioritization here is producing the highest business value as soon as possible for the customer. That's why Agile projects have got a reputation, quite rightly too, of improving return on investment. So once again, you and I will be talking about the product backlog items, where each item is a feature, often represented as a story. But I want you to see right now that if you were creating, let's say, a new food blender for the average household, then you could see you'd have a set of features you'd want to include on that food blender. A feature might indeed be your physical design, as well as the functions that are inbuilt within the food blender. So although the product backlog is an Agile term, to ensure you get the most benefit out of this training, I want you to start thinking about the product backlog as merely a device that plays its part in the reduction or banishing of technical debt. So continuing on Agile projects, what we have to start with is our outline requirements, and you would have a project manager in more of a facilitation role, helping to ensure that the team have got everything they need and that they can work to their optimum efficiency and effectiveness throughout each sprint. Over here, you can see how sprints are cyclic. So for example, in a particular management stage of a project, you may have several sprints, one after the other. It starts off by taking the relevant features from the backlog, which I've just described broadly in the previous slide. We then carry out sprint planning of the sprint itself. These are taking those features and estimating what the work effort will be needed within the sprint, and then the sprint continues. A sprint, typically in Agile, will be no longer than 1 calendar month. Typically, it may only last a week, or in certain circumstances, just a few days. What is important, within the sprint, the team themselves will have what's known as a daily stand-up or daily review. No more than 15 minutes, and it's done standing up to make sure it's quick, where each team member will describe what they did yesterday, what they're doing today, and any problems they need help with. It's not there as a status meeting, merely to make sure the team continues to work efficiently and effectively. As you get towards the end of the sprint, you have what's known as a sprint review. Typically, this is where your products would be demonstrated to the customers and users and feedback received. Then something called a sprint retrospective, which is looking back on the process, the way in which the sprint was run and managed, and seeing if there's any learnings that we can apply to future sprints, particularly the one that's coming up next, and the cycle continues. Now, this of course is all designed for software, but what if you're creating a new process for use within your organization? Or, as I've said earlier, you're developing your latest model of food blender. Well, the answer is you could still continue to carry out using sprints if you wish, or perhaps you have a very well understood traditional project management method that works just fine. If you do go the sprint route, then you could see perhaps at the end of your first sprint, you could have a very early non-working mock-up or prototype, and you gradually embellish on that as each sprint continues. So, with Agile, you'd have a high-level plan, not in detail at all, because of course the product will be created iteratively and incrementally. Let me just define both of those in straightforward language. Incremental comes from the word add on to. What this is about is you build as much as you need right now. For example, a part-working prototype. Then repeat and produce another piece of final tested product. Then you add on to, hence the word, the existing chunk, piece of work, and build upon it. And the focus here is only on the requirements that have yet to be implemented. If you remember the backlog in the previous slide, those are the requirements to the left. So in effect, each sprint is driven by those features remaining on the product backlog. What does increment mean then? Well, increments are units of work that will be project managed. Each increment is developed iteratively. And what about iterative? Well, that comes from the term to alter. Here, you don't finish a feature in one go, as I've inferred here, but produce a best first pass for a product, like a part-working prototype, and then review it, then improve it, and keep iterating until done. So can you see that at the heart of Agile, it's a combination of both incremental and iterative working, carried out by the process of sprinting. So here's how it might look in stage one of an Agile type project. If you're calling it stage one, you'd have one increment, then a second increment, and a third increment. Each increment might be fulfilled by one sprint or several sprints. And in Agile, you'll be working closely with the business and the customer and the users. And the development team will be creating the plans as they go. Indeed, you will have a sprint plan back here at step 2, in detail, just with regard to that sprint. And the analogy here, rather than a train on tracks, it could be a sailing trip. This has an end goal, but the journey path is less predictable. Another analogy I've seen of Agile is a bit like a guided missile. Once they are launched, they're using radio signals to track and control their ultimate destination. And therefore, as the missile travels from its launch to its destination, it is continually making adjustments to make sure it completes its mission. So there we have it, a quick broad brush approach, giving you a definition of what technical debt is all about, and a reminder that there are an almost limitless amounts of products and services out there, and there are various project management methods of delivering them. So Module 1 has given you a firm foundation ready to move on to Module 2, where I shall investigate a little further this idea of iterative and incremental approaches, as well as introduce you to Ward Cunningham, who first envisaged the term technical debt. So thanks for your time and attention. I look forward to your company on Module 2. From me, Dave, it's bye for now.